Okay, I think we're rolling now. Okay, so first of all, just to kind of give you a little bit of background on what we're talking about, and also me. So I have a PhD in computer science. I've been teaching computer programming, computer science for about almost 18 years now. I've started three or four different software companies and sold them, and the four because there was one that was in a partnership, blah blah blah. But in any case, I've been doing this for a little bit, and I kind of have this philosophy that computer programming is a skill set, and so many people get stuck into these holes where I'm a Java programmer or I'm a C# programmer or different things like that. And I like to kind of bring the focus back to computer programming as a skill set, and then try to look at the small differences between our languages and how we got to where we are today by taking a look back kind of to the quote beginning. Although I like to look at kind of C as our starting point. But in any case, that's maybe the background here. So we're going to spend today talking about what computer programming is and why it's difficult for people. And for those of you who are watching this who maybe are advanced programmers, hopefully there will be pieces of this that fill in some knowledge gaps for you, or maybe make you think about things a little bit differently than you thought about them before. If you're new to programming, which is kind of maybe the target audience for this kind of recurring workshop from Thinkful, is we want people to come in kind of with the right expectations of what it means to be a computer programmer, what kind of path you have ahead of you as you start learning. So we'll kind of see where it goes. If you have any questions as we're going along, go ahead and pop them into the chat. I'll try to keep an eye on it. If I get carried away or something like that, just put a bunch of asterisks in there or something like that and just pound on the keyboard. And hopefully you get my attention. We probably will not finish this all in one session. The last couple versions of this we did in about 2 to 2.5 sessions. I usually go about an hour, so if you have to bail early, we are going to be doing a recording of this, so we'll get it up somewhere. I don't know where we're going to post it, but it'll be somewhere. And but plan on staying till 10 o'clock Central or so tonight, and then we'll do it again next week, same time, same station, blah blah blah. Okay, so having said that, let's kind of dive in here, and kind of where I like to start. So I grow a kind of a keynote presentation, and I'll paste the iCloud share to this keynote presentation in the workshop notes, so you have access to it if you want to make a copy or reference it for next week or whatever. But I kind of grow a keynote from scratch, as sometimes the workshops go a little bit different directions depending on questions that are asked and things like that. So that's why I'm not starting from a copied slide set. But in any case, the first thing I like to talk about is how humans solve problems. All right, so this kind of goes back to the kind of the beginning of why we, what problem we're trying to solve as computer programmers. So in order to do that, we need to think about how us as human beings solve problems to begin with. And I like to think that we solve problems using our memory, asking questions, and repetition. Okay, so that's how we as people solve our problems. In general, we always solve problems in terms of the tools that we have available to us at that moment. And these are kind of the tools that we're guaranteed to have available to us. All right, so now we want to think about what is the job of a programming language. So at the 10,000 foot view, it's going to be to let us tell a computer what to do. So that's 10,000 foot view. 2,000 foot view is going to be something along the lines of allow us to solve problems similarly to how we already solve them and still tell a computer what to do. All right, that's a little bit of a trickier problem to solve, pun intended, I guess. Computers are the kind of the mentality I want us to have as we kind of think about computer programming is, and I'm going to kind of throw a few ideas out here, and then we'll We'll talk about each of them in passing and then wrap them back into future discussions on other slides. Is first of all, I want you to think of a computer as kind of like an alien. All right, all of us are really, really, really good at dealing with other human beings, but now we got this weird alien being that is our computer, and we really don't know what to, what to think of it or how to communicate with it. It doesn't come naturally for us. Okay, so that's kind of one piece of given information I want us to have. The other piece of information, maybe the nugget of truth that I want to put in your head, is I want you to think about computer programming as kind of like a sport. Okay, so usually I ask my students, do you play any sports? And you get a lot of soccer players or tennis players or golfers. So I'm an avid golfer. So let's use that as kind of as a starting point. So I've been playing golf for about 6 years and I've gotten pretty good at it now. But when I started, completely sucked. All right, I'd watch a zillion videos. I took all these lessons, blah, blah, blah. But at the end of the day, I could academically understand how to hit a pitching wedge. But for the life of me, I could go out there and just hit bucket after bucket and after bucket of balls, and I would just shank it all over the place. I'd swing and miss sometimes, all this other stuff. Programming is kind of the same thing. It's where you can academically understand different aspects of computer programming. You can academically understand what an if statement is, or what a loop is, or what a function is. All these things you can have that academic knowledge, but until we've put the reps in and actually started applying it to solving real problems, we don't really have any competency. We have knowledge without competency, okay? So that is a truth, and that is a truth for all programmers regardless of the technology to which you're applying it. So I don't care if you're a Nodejs guy or an Android programmer or an iOS programmer or a Python programmer. It's all the same crap. All right? It's all the same crap, and you're applying that computer programming as a skill set to a technology to solve a problem within a certain, let's call it a genre I don't even know. Let's just call it a genre of solution. All right, probably a made-up phrase, but let's just pretend it's something legit. All right, so punchline here is that the job of a programming language is about meeting us way more than halfway. So instead of having us learn how to talk to this alien being that is a computer, we're instead going to leverage this idea that human beings are already really good at dealing with other human beings. We already have that skill set. So if the programming language can act as a power tool and allow us to not have to change the way we solve problems too much and still communicate with the computer, then the programming language is kind of doing its job. And we're going to talk about this through the evolution of our languages and see how it was doing that job and how it started not being able to do that job as we talk about the evolution of C to C++ and so on and so forth. All right, so now we have to look ourselves in the mirror and understand the problem. So what's the problem? The problem is us as humans. Humans are so good at solving problems that we have trouble articulating how we solve them. Okay? That's another truth that I want us to remember as we go through here. We have become so good at solving all the problems that are around us on a daily basis that we have lost this ability to tell other people how we solve those problems. Usually the first day of one of my college courses, I'll ask my students, how many of you got to class today without bumping into any walls or anything like that? And you got the couple of smart asses that say, oh yeah, I bumped into a wall. But in general, you look at folks today when they're walking in from the parking lot or whatever, it's not even worth their attention to pay full attention in front of them. They're texting while they're walking. They're bobbing and weaving in and out of people. They didn't hit any walls. It's not even worth their full attention. Okay, even we break that down, all the steps of going from the parking lot to the classroom, let's say, just the act of walking. Okay, one little piece of that is such a complex problem to solve, and it's not even worth their attention because human beings have been doing it for so long. All right, most beginning programmers or even advanced programmers that when they finally get to the point where they can accept that there's so much stuff they don't know, Because before that, they kind of think that they're a rock star or something like that. It goes to their head, and then they transition. But the idea is that they look at things that are around them, things they don't know how to do. Like let's take a fancy schmancy video game, like a Battlefield. Okay, or pick your favorite really cool video game that's out now. All these explosions and lights and zillions of things happening on the screen at once, to most people, we would perceive that that's a really, really, really difficult problem to solve. Now, the reality is that problem is absolutely trivial compared to the problem that we are solving on a daily basis, just getting out of bed or walking down the hall, or doing a bunch of other things that is basically mindless to us as human beings, okay? So it's not that computers are really, really complex. It's not that the types of problems like writing video games and things like that are so far beyond us. It's that we are so good at solving problems that it's very difficult for us to slow our mind down, to break things down into baby steps and actually tell this stupid alien being that is a computer what to do. All right, and that's where these programming languages come in. Okay, they're trying to be that power tool for us. All right, so having said that, the next slide I like to throw in here, I'm going to drag it down here, is I like to call this guy the mapping. 100% of programming languages, literally 100% of them, will have facilities for these three things. All right, so we'll accomplish memory through variables. We'll accomplish asking questions through conditionals, usually if statements. And we'll accomplish repetition through loops and methods or functions or subroutines. Choose your poison, all the same thing. All right, so every single programming language will have facilities for these three things. So if you have acquired computer programming as a skill set, learning a new language becomes very easy. All right. For those of you in the audience who speak more than one language, okay, I speak English and bad English, I guess. But I know many, many, many people who speak multiple languages, and I've done the research, and this is another truth. When you're talking to let's say you got a person who speaks English and another person who speaks Spanish, okay, or the same person who speaks Spanish. When they're speaking to their English-speaking friends, they're using the exact same problem solving in their mind as they're using when they're speaking to their Spanish-speaking friends. The only difference is the words that are coming out of their mouth, the quote syntax, is a little bit different, okay, even though they're solving the same kind of problem, right? They're dealing with a human. Same thing's true for us. When we're dealing with a computer and we're interfacing with this computer using different programming languages, whether it's Python or Swift or Java or whatever, you pick your poison. Okay? These are just like various natural languages that humans use to talk to each other. Each one has its own little nuances and sounds interesting and all this other stuff. And some of them might be, their complexities might lend themselves to articulating certain types of ideas better than another language might be. But at the end of the day, they're all solving the same problem, allowing a human being to talk to another human being. Okay? So throw this idea that the programming languages make a difference out the window. All right? If you know one language, if you know computer programming as a skill set, and I introduce a brand new language to you that you've never seen before, in 10 minutes I can teach you how do you do variables, how do you ask questions, and how do you accomplish repetition in that brand new language, and you can already solve a large classification of problem in that brand new language that you just learned today. All right? Again, this is a truth. Now, a couple other things I want to throw in here. I want to demystify a couple of things. So we have buzzwords that float around out there, and so I kind of have, I'm in the double whammy section of this guy. So in academia, PhDs like to use big words to make themselves sound smarter, right? So all my colleagues are running around and, they try to intimidate the people around them by just using big words that mean simple things. Technology makes this even worse because technology is the king of buzzwords that sound cool that mean simple things. All right, we're surrounded by these things. In fact, if we go through the history of technology, the same technologies are fed to us multiple times with rebranded names on them. And until we know better, we're meant to think that these mean the same thing. Okay? So let me give you a couple of examples of this. All right, so I'm just going to use one example that comes to mind here. So let's take JavaScript. All right, so JavaScript is, let's just put it in context for what we're dealing with here. This is going to be the dynamic programming language for websites. Let's say that. Okay, now why am I saying it's the dynamic programming language? Well, just a few minutes ago, we talked about what are programming languages, and we said that all the programming languages have facilities for these guys right here. What that essentially means is things that are not programming languages. Those are going to be things like HTML, CSS, JSON, XML. These are not programming languages. You can throw HTML5 and say, okay, well, technically you can do some of that stuff, but generally speaking, these guys are not programming languages. That doesn't mean they suck. It doesn't mean they're stupid. It just means they're solving a different problem. For instance, HTML is a data representation language. It's a language that's meant to represent the data that you want your web browser to interpret and turn into pretty pictures and text on the screen. Okay? So, the idea here is that we just want to compartmentalize what these guys are. So since our websites are front end, and we'll talk about that here in a little bit, but since our websites, we'd like to have them do dynamic things instead of just being these static pages that don't do anything. Since we want that, we need something to complement HTML on the web page, and that's where JavaScript comes in. Okay? So that's the context for kind of this example here when we deal with buzzwords. So JavaScript's the programming language that complements the data representation language of HTML for a user who's experiencing a website. All right, well, anything that's happening dynamically on a web page, well, it's actually kind of a lie too. Most things that are happening dynamically on a web page are happening through JavaScript at some level. Now, we've heard some other technologies thrown in there, like Ajax. What's Ajax? Ajax is a JavaScript library that lends itself to dynamic sites that only reload portions of the page. Okay? Prior to Ajax, when people were just using JavaScript, which is completely different, right? Even though it's not, what we were doing is we would typically reload the entire page to make something dynamic happen, as opposed to rewriting the document object that the web browser maintains for showing your current page on the screen. All right, fine. So we came out with a special library for JavaScript, or a special JavaScript library called Ajax that allowed us to more easily accomplish reloading only portions of a page to improve the end user experience. Still JavaScript. Ajax is just a JavaScript library. Well, then, you know what? Ajax kind of fell out of vogue. It wasn't cool sounding anymore, although it is a kind of a cool sounding name. So what did they do? Well, they came out with jQuery. All right, so jQuery, we're going to basically say this is pretty much the same crap. Just copy that down here. So it's a rebranding of Ajax. It had an evolutionary jump where it did a couple of things better than Ajax did, but at the end of the day, it had kind of the same goal, and it was still a JavaScript library. All right, but to most developers who haven't necessarily been exposed to these things, these are buzzwords that are floating around out there that just make us feel like there's so much that we don't understand. All right, so let's go farther down the rabbit hole. Let's go Angular. All right, what's Angular? Let's just say that's the same crap. All right, so fine, it's a rehash of the same stuff, and it adds a couple of other bells and whistles into this thing, but at the end of the day, same exact thing. All right. Well, where else can we go with this? We could say, oh, React. That's another cool kid today, right? Pretty much the same thing, but from somebody else, right? That's the Facebook and Twitter people working together. It's Facebook and Twitter, right? I'm gonna brain fart. I'm pretty sure that's what it is. Close enough. Two of the big social media folks put this together. End of the day, every one of these is a JavaScript library that solves basically the same problem in an evolutionarily improving way, let's say. All right. So, one thing I kind of want to just throw out there, the purpose of this slide right here is this idea that there's a lot of intimidating buzzwords that are floating around out there that are almost meant to make it more difficult for us to break into the computer programming world. But I'm promising you that every one of those buzzwords fits into about 4 or 5 different buckets, which represent the technologies that they relate to. All right, so let me take that a step further. So let's go down and let's just talk about web programming for a few minutes and demystify that a little bit. So if you're already a web programmer, you probably already know this stuff, but I'm going to hopefully, again, fill in some knowledge gaps for you. So we're going to draw a couple of pictures here. We're going to start off with, this is going to be the server. Oh, and in case you haven't been impressed yet, I am a keynote ninja. This is all right, so here's our client, there's our server. We'll make the client orange. See, told you, ninja. And so this is the, in computer networking, the client-server model. All right, where the client talks to the server and the server serves information to the client. All right, and this could happen at McDonald's where I'm ordering a Big Mac and the cook in the back is making me a Big Mac, or it can happen in our little computer world here where our client, for instance, in web applications would be like a web browser, right? So this is our web browser, is our web client, is our client in the web world, and this is our web server over here in the on the server side. All right. Oh, so wait a minute. I just said a couple of buzzwords there that get thrown around. So let's give some meaning to those. So this is often called client side. This is also often called front end. Okay, these things are all synonyms for each other. The client, the web browser, client side, front end. Anything that's happening inside of your web browser is a client-side technology or a front-end technology, something like that. Similarly, on the web server, this is server-side. We also have back-end. All right, so if somebody says, I'm a back-end programmer, I'm a server-side programmer, they're just talking about they're writing stuff on the server side of the equation. And what does the server side of our equation do in a web server type world? Well, let's just draw a little our line in here. Oh, there we go. I'm going to save this real quick because Keynote just gave me a little spinny pinwheel thing. All right, so here's this communication channel between our client and our server. If I'm at McDonald's, I'm going to say I want a Big Mac, and the server's then going to put in the order for a Big Mac. Well, in the client-server world here, the client is speaking the HTTP protocol. All right, so the language that the client speaks to the server is the HTTP language. All right, instead of English, instead of Spanish, it's HTTP. That's what the client uses to request information from the server. The server then always sends information back to the client in the form of HTML, JavaScript, and CSS. Let's just leave it at that. We can probably make this a little bit more complex than that, but this is fair enough for this example. All right, so no matter what the client asks for, the server always spits back HTML, JavaScript, and CSS. Because that's what the web browser understands. Your web browser, whether it's Chrome or Safari or hopefully not Internet Explorer, but if it is, it's dying soon, so we'll be all out of our misery. But in any case, those guys understand HTML, JavaScript, and CSS. They receive things in that data representation language, and then convert it into pretty pictures and text on the screen. All right, that's what web browsers do. Okay, anybody who's digesting, any user who's digesting a computer program through a web browser has to digest it in terms of what their web browser is able to show them. Any computer programmer who's writing a web application meant to run inside of a web browser has to solve that problem in terms of what the client, what the web browser can do. If you've ever seen the movie The Matrix, which most technology people have, remember Morpheus said something to Neo that all systems have rules and those rules are made to be broken and blah, blah, blah. Bottom line is, in The Matrix, people could do things that they couldn't necessarily do in real life. All right, same thing is true here. We have limitations or things that we can pull off inside of a web browser because this is our matrix as a programmer. All right, anything that we write on the code side of things gets translated and interpreted by the web browser and then ultimately gets shown to the user. All right, but the output of our programs over here on the server will always spit out HTML, JavaScript, and CSS. 100% of the time. I don't care what technology you're using over here. Okay? So let's talk about some of these technologies that exist over here on the server side, and then we'll talk about some of the technologies over here on the client side. So web servers come in a couple of different flavors. Well, we're going to start off with kind of an industry standard enterprise type of web server called Apache. All right, so the Apache web server is probably running on, I don't know, 75 or 80% of web servers on the internet today. I might be completely making that up, but it's common. All right, so the idea here is that the Apache web server, this is an enterprise level web server that's been around for a long time, pretty much since the beginning of the internet. All right, now typically, well, let's say in the early days of Apache, the server would run programs, and those programs would maybe be written in a language like Perl, let's say. All right. So Perl was an old scripting language that a lot of Unix system administrators used before the birth of the internet. So kind of in the mid-90s, somewhere in that ballpark. And then when the internet became a thing, and we had this web server, and we had people who wanted to have web pages that did more than just show text on the screen. Instead, they wanted people to be able to type stuff into a text box, hit a submit button, and something dynamic happen. We had to have some language on the back end that could take in what the person typed. You know, if I typed in a username and password on the client side, and I sent that to the server through the HTTP protocol, the server then receives it, has to send it into a computer program. Let's say that early program was written in Perl. All right, that Perl program then needs to interpret it and decide what do I need to give back based on this input. And then they would spit out the result, but that result would be HTML, JavaScript, and CSS. That would be the output of that Perl program. All right, in the very early days, there was because this was a web technology and it was being married to a pre-web technology, there was a little dude there in the middle called CGI, Common Gateway Interface, that kind of glued these guys together. All right, kind of unimportant in our world. We can go as deep and down this rabbit hole as we really want to, but punchline here is that this is a programming language, this is a web server. That's what I really want you to get out of this, okay? Now, other programming languages that we've heard of. PHP, right? Also a programming language. Let's keep going down the rabbit hole. Ruby. Python. I'm going to throw a top secret guy in here for a second. We'll say Node.js in there for a moment. Don't let the JS throw you a curveball here yet. All right, so these are all programming languages, let's say, and kind of just take your glasses off for this guy for a moment. We'll demystify that in a second. Okay, but these guys are all programming languages, and they're meant to run on a web server, but any one of these guys ultimately is going to spit out HTML, JavaScript, and CSS. Okay? If you write your program in PHP, it's going to spit out that. Ruby, it's going to spit out that. Python, it's going to spit out that. Doesn't matter what the language was. It's solving the same problem because we are solving the problem of web browsers talking to web servers. Okay, so let's jump in here real quick. Let's call this server-side. All right, so I'm going to omit Perl from this example because it's just it existed historically because we had to start somewhere. But I'm going to throw PHP in here. I'm going to throw Ruby in here. We're going to throw Python in here. And then we're going to throw Node.js in here. All right, now PHP ran on a web server called Apache. All right, so in order to get PHP, as a web developer, if you were a PHP web developer, even if you are today, it's still very popular today, what you would have to do is you'd have to get Apache web server installed. Then you'd have to install the PHP module for that guy. Then you'd have to write your program on your desktop and upload your FTP, your code up to the server, then test it through a website. There was a kind of a cross-training type of skill set that was required for to be that kind of programmer. You couldn't just be a programmer and immediately sit down and start writing your software. You had to also be kind of an IT person. All right, so PHP. Great language, still around today, but it's still around today and still popular today because a lot of third-party tools have come into existence to make those complications go away. All right, but we're gonna talk about that in a little more detail, but I'm gonna write each of these guys in a different way here. And most of that is gonna be because of Ruby's fault. Nobody ever thinks about Ruby as a programming language, right? We always think about Ruby on Rails. Because it just sounds cool, right? Ruby on Rails, or sometimes the cool kids, they say, so I'm a Rails developer, okay? Well, what does that mean? That means we have a programming language called Ruby that's running on its own built-in web server called Rails. So I can write this as PHP on Apache. I can write this as Python on Flask. And I'm going to rewrite Node.js as JavaScript on, I'm going to say Node. You can replace that with Express if you're a Node.js programmer, but let's just go with Node for now so it fits my generic model here. All right, so we're going to say the problem with PHP, okay, the early problems with PHP is that this guy required an IT skill set to set things up before you could actually start programming. All right, that was the problem with PHP. That's why a technology like Ruby on Rails came out. There was a secondary problem, and MVC was not supported. All right, so remember a few minutes ago we talked about buzzwords? Where were those guys? Buzzwords right here. So MVC is one of those guys. So let's pause this for a second and go talk about MVC. But in order to talk about MVC, we really need to talk about design patterns. Oh, this is more of a buzz phrase, I guess. So I'm assuming that most of you in the audience have heard the phrase design patterns before. You've heard MVC before. You might not know what it means. You might not know what any of that means, but you've heard it before. Or you went to work and you got that jerk at work who just says all these buzzwords that makes himself sound smart until you start realizing that they all mean simple things. That's hopefully what we're going to be accomplishing here. So what's a design pattern in general? A design pattern in general is, here's the earth-shattering definition, a suggested good solution to a, quote, common problem. All right. What is it? So two pieces here. What does it mean for something to be good? And what does it mean for a problem to be common? All right. So and design patterns are really they're the friend of me and my colleagues because we have to publish or perish as PhDs. So the idea is that with design patterns, all we have to do is come up with a common problem for somebody, and then a proposed, hopefully good solution for that. And then the other requirement for design patterns, it also has to have a funky name. Okay, if we can give it all three of those things, we can get a research paper out of it. And even if our suggested solution isn't as good as we thought, and the problem isn't as applicable to as many people as we maybe had hoped, we still get the publication, we still get the credit, and life goes on. All right, so a design pattern is nothing more than a suggested good solution to a common problem. Having said that, I'll talk about 3 popular design patterns that are out there today. At the end of the day, there's a zillion design patterns because a zillion things fit into this category. All right, if you work for Lockheed Martin and do something with rocket launches, maybe a common problem for you is fuel consumption for rocket engines. Okay, that's certainly not going to be applicable for a web programmer. Okay, so design patterns come in all sorts of shapes and sizes, but we're going to list 3 of them here. We're going to say MVC, we're going to say observer, and we're going to say the singleton design pattern. Okay, so all these guys seem mysterious enough for us, I guess. All right, but because in context here we were talking that one of the problems with PHP is this problem that it lacks MVC, whatever that means. Let's define MVC. MVC states that it is a good idea to separate your code from your design. That's it. That's what MVC says. Keep your code in one place, your design in another place. In PHP, so a language like PHP, what you had basically an HTML document that had embedded in it some PHP code. So you had this mishmash of logical code that was written in PHP as well as data representation code in HTML. All right, and what differentiated those files? Instead of your web browser requesting the file, let's say index.html, it would instead request a file like index.php. The contents of those 2 files could be literally identical to each other. No differences, all right? The only difference here, though, from a web server's perspective, is that each of these guys has a different what's called MIME type. Okay, fancy way of saying what kind of file is this. So for instance, if you're on your computer at home and you open up, you download a file off the internet or get it as an email attachment that's a .doc or .docx, and you double click on it, its MIME type is Microsoft Word, and you expect Microsoft Word to launch. That's how MIME types are used. Based on the extension on the file, it fills in, it follows a certain MIME type, and based on that MIME type, a certain application is called. So when the web server receives the index.php file, it knows that before it just gives you the result back, it has to first pass that file through the PHP module that we talked about earlier. So there's a PHP preprocessor that lives on Apache, the PHP module, that will take this program and run it first, and then spit out the output of that program, which will be HTML, JavaScript, and CSS. If your MIME type is just HTML, that means that this file has already been processed. It already contains the right kind of stuff, that is HTML, JavaScript, and CSS, so the web server doesn't have to pass that through any sort of preprocessor. It just spits the file back to the client because that's the file the client requested. Okay? But weakness of PHP here is that it didn't support MVC. That is, natively, the PHP technology said, let's embed our PHP code inside of our HTML code. Now, today we look back and say that might be a stupid idea. Well, that was a stupid idea because now MVC has taken over and everybody has their own little twist on how MVC is implemented. All right, but the punchline here is we have to give some credit to PHP. When PHP first came out in the early days of the internet, it was really our first web-specific language, or right up there in the top couple. All right, when it came out, the types of web applications we were writing were far, far less complex than the types of web applications we're writing today. Okay, so what does that mean? That means that back then, having some PHP code sprinkled into your HTML code wasn't that big of a deal because it wasn't that much stuff. It wasn't that confusing. There wasn't this huge need to separate them. Okay, but now, we're writing really, really, really complex websites, and the web is making a comeback, right? So several of you in here, I'm sure, are probably web or front end programmers. Then some other others might be mobile dev programmers, iOS, that kind of stuff, or Android. But the punchline is that we're seeing a resurgence on the web side of things today. Because we're so much more capable with our technologies. We can deliver stuff through the web that transcends this idea of what used to be a desktop application versus what now runs in a web page. The evidence there is we see like the success of things like the Chrome OS, where Chrome OS is essentially a web browser that is, when you go out and buy a Chromebook, it's basically Chrome running on some laptop hardware, and it's delivering a whole user experience that's considered adequate. All right, so in any case, PHP could have fallen to the wayside because it didn't support MVC and had a little bit of a learning curve and ramp up period before you can actually start solving your problems. All right, so what did Ruby on Rails bring to the table? Well, it came with its built-in web server. Okay, called Rails, and built in MVC. So, what is MVC? When the web world, what's MVC typically? What's the solution typically called? It's usually called a templating engine. So, templating engine is how MVC is typically solved. And that's why things like PHP have survived. So what do we have with PHP? Well, the first problem has been solved by third-party hosting sites, like, let's say, GoDaddy, that let you host a PHP app. You give them $5 a month, and they handle all the web server IT crap for you, and you can just work. And then on top of that, we have third-party developer tools like, there's tons of, I guess Dreamweaver is the one that comes to mind, where you can write your code in in Dreamweaver and just hit the save button and it automatically uploads it to the server. So from your perspective, you didn't have to do any weird FTP stuff. Similarly, there's a ton of third-party templating products for PHP that allow you to now accomplish MVC, separate your PHP from your PHP code from your HTML. So that's why PHP didn't die off. It's a great language, just the technology was a little bit ahead of its time. Maybe we could say that. But punchline is that we revamped it and made it still viable today. But Ruby came with its own built-in web server, and then came with its own MVC templating engine. So solved a lot of those problems, and it's still popular today. What were the problems with Ruby, though? I would say the biggest problem with Ruby was that it has a very specific directory structure. All right, so you kind of have to learn the Ruby way of doing things to do things on Ruby. All right, not necessarily a problem. A lot of really famous websites have been written in Ruby. Sites still come out today that are written in Ruby. And realistically, if you're writing something that is purely for web, and that's the only platform it's going to end up being on, it would be hard. You'd be hard pressed to beat Ruby for let's build a powerful website quickly type of concept. But unfortunately, in today's world, what we consider to be our front end for our applications typically goes beyond web. A lot of new applications that come out, the front end could be a website. It could be let's use Slack as an example, since Thinkful uses Slack so prevalently. So the Slack application runs in a web page. There's a Windows native application for it. There's a Macintosh native application for it. There's an iOS application for it for iPhone. There's an Android native application for it for Android. So it's one application, one server side, let's say, that has a whole bunch of different front ends. All right, so different ways of experiencing that product. And when you're looking at something like that, a technology like Ruby is going to break down pretty quickly because it's so focused on web. Okay, and takes away some of that other flexibility. Doesn't mean you can't pull it off. Okay, remember, programming is the skill set, and we can apply it to all sorts of different types of problems. So now we get down to Python on Flask. Well, there's two stories here with Python on Flask. The first story is that the Python developers were getting a little jealous of the Ruby developers. So they would look at the Ruby developers and say, well, why do they get to write web crap and we don't? So part of it was that. The other piece was this last part here where in order to become a Ruby programmer, it required that you not only have the computer programming skill set, you also now had to learn the Ruby way of doing things. Where what did Python bring to the table? Flask is the web server, the third-party product not built into the technology. Rails and Ruby are kind of married together. Okay, there's a third-party thing called Gems that Ruby allows you to bring in third-party things, but Python actually separated. Well, not even separated. Python pre-existed, and then they added to the Python web developer experience by bringing in like a third-party web server like Flask. All right, so this lets you do everything that you can. Let's see, that can be done with Ruby, but without the directory structure limitations, let's say. Okay, and also you now have more flexibility with what third-party products you might choose to use. Same thing is true with Ruby on Rails to an extent, because there's tons and tons and tons of gems out there. But Python is a pretty vibrant community with pip for what third-party tools you might be able to use. Okay. Now, so we're going to say that all three of these technologies are identical to each other. They're all accomplishing this exact problem, or their solution to that exact problem. A web browser talks to a web server and receives HTML, JavaScript, and CSS. Okay, and these are spanning 25 years, these technologies here. What's Node.js? Oh, that's the new kid. Okay, so Node.js brings this to the table. It's, well, first of all, your back-end language is the same as the front-end language. All right, so that's one thing you run into with Node.js. Now, I'm not necessarily a proponent of that, since I started off by telling you that I think computer programming is the skill set and the language doesn't matter. Okay, but until you've done it for a long enough time, a front-end developer who is familiar with HTML, CSS, and their dynamic programming experiences in JavaScript might feel less intimidated going over to the server side of things, writing server-side codes, using a language that they're already familiar with. So while I'm telling you that's not necessarily a big deal, to somebody who's just getting started on server-side or back-end programming, it might make it a little bit easier pill to swallow. So we'll call that an advantage of having JavaScript on the back end. All right, so back-end language is the same as the front end. Also, Node is very scalable. All right, so the world we live in today, especially with the resurgence of our web applications, let's say, and web applications being used for a bunch of different things, now we have this need for our web servers to be able to handle thousands and thousands of simultaneous connections. And Node scales very well to those types of things. It's not that Node is doing anything that what hasn't already existed. It's just putting things together that we've learned about in the past into a single solution. How does Node really pull this off? Well, Node has this idea that, let's kind of just draw another picture. And let's look at this through the lens of authentication. So authentication has been around since the beginning of the internet. So authentication, typically you have the server that sits here, and then you have a client. Well, in our model here, we have several different clients. So, you have a bunch of people sitting at their computer all talking to the server, the same single server. All right, so when this client comes dialing up to the server, what is not appropriate is for the server to authenticate this first client while everybody else waits in line. The human concept of fairness, the human McDonald's ordering process is not appropriate for computer applications, right? If you go into McDonald's during the lunch rush and there's only one window open, one only one cash register open, and the person in front is browsing the menu and delaying the whole line, people behind get upset. All right, so what's our solution to this in the computer world? Well, what the server does is they typically spawn off a thread. Okay, a little thread of execution. So you can think of these guys like worker bees. All right, we're gonna make threads. They're gonna be little red dudes. So they'll spawn off a little worker bee to authenticate that guy, and then they'll spawn off another worker bee to authenticate this guy, and another worker bee to authenticate this guy. So now you can have a zillion guys come onto the hit the server, and the server spawns off the worker bee, then goes back and waits for the next person in line, then sends them off with a worker bee to get some work done. Okay. So we might say, oh, well, that's a good solution, but we're not to the node solution yet. Okay, this is the prior to node solution to this. The issue here is that while this sounds great on paper, threads are expensive. Okay, they're not the most expensive way of accomplishing this. If we were talking about an operating systems course, we would have gone back before this and talk about spawning off child processes and stuff like that, which are even more expensive. But punchline here is that whenever we spawn off a little worker bee, however it's working, there's an expense associated with this. So creating this worker bee in the first place takes time, and each of these worker bees take away from the CPU time that the server has. Okay, or take away from the CPU time on that machine that could be spent doing other things. All right, well, having said that, the idea that Node has come to the table with is this. You know what? Rather than spawning off a zillion threads every single time somebody is trying to connect, which, by the way, in the middle there, before Node came out, what they would actually do is they would create what was called a thread pool. So we'd have several threads kind of pre-spawned sitting up here, ready to help. All right, so when somebody else came in, the server didn't have to spend time spawning a thread. They would just assign an already spawned thread to go and help somebody. All right, so that was, kind of as we've seen the technology evolve, that's what would happen. But what Node decided is, you know what? There are really two different things that are happening on a server. There's I/O stuff. So we're going to call this guy an I/O thread. And this is then number crunching thread, NCT. Okay, so only two different types of things that happen on our servers. Things that are I/O bound and things that just need number crunching. So when somebody's being authenticated, that's an I/O bound type task. So we'll put them in line for the I/O thing. If things need number crunching, we'll go ahead and put them in line for the number crunching thing. All right, well, just a few minutes ago, we said, you know what? Waiting for somebody to sign up, for somebody to sign in, even though that's human version of fairness at McDonald's, doesn't really work in a computer scenario. But now what we're doing is the server's still able to receive incoming calls because they have one worker bee handling all the authentications and another worker bee handling all the number crunching. And then while a user is thinking about typing in their username and password but hasn't actually typed it in yet, they're not taking up either of the lines. So this is the person at McDonald's waiting to order who then finally says, oh, I know what I want, and they actually step into line. And this guy, even though he's serving these guys on a first-come, first-served basis, to actually process I/O is very, very fast from a human's perspective using modern technology. Our computers are really fast. All right, we take advantage of that with the Node technology. All right, similarly here, number crunching things happen very, very quickly. So in the node model, we have a relatively few number of threads. I'm oversimplifying this here with just 2 threads, but we don't spawn off a thread for every new person that comes in. We have a relatively few number of threads, and we leverage how fast the computer under the hood actually is so that systems can become very scalable, as opposed to getting bogged down, not with too much work, but with managing too many employees, if you will. All right. A McDonald's would slow way, way, way down if you had 2 customers with but 5,000 employees running around the place. Okay, so that's really where Node falls into this category. All right, so punchline. All of these guys, even though they span 25 years of web programming, are solving the exact same problem. We have a server-side programming language working through a server, a web server, whose ultimate job it is to serve HTML, JavaScript, and CSS to a web client. And it accomplishes that through various programming languages using various technologies like Apache, like Node, or Express if you're a Node programmer, like Flask, like Rails. Okay? All of these guys can be put onto this exact same diagram. They're all solving the exact same problem. Okay, so that kind of deals with maybe our web world side of things. Where I'm going to kind of start next time, I'm going to pre-create a couple of slides so you kind of see where we're going. We're going to talk about the evolution of C. We're also going to talk about these other design patterns in here, so I'm actually going to drag that guy down here to the bottom because I do want to introduce those. So we'll talk about the evolution of C. We'll talk about the evolution of C++. And I'm actually going to quickly create a kind of a governing picture that we're going to use for that. So up top here, I'm going to draw C. We'll shrink that guy down, and we'll make him. All right, so that's C. Here's C++. I'm going to go ahead and throw Objective-C over here. And then we're going to say Java. Talk about Java. Then I'll throw C# in here. Talk about the evolution of C#. We'll throw Objective-C 2.0 in there. You know, yay to Apple for their naming conventions. So Objective-C 2.0. And finally down here we'll throw in Swift. All right, so we're going to talk about the history of our programming languages through this lens. And the thing we want to keep in mind is over here, we'll go ahead and fill in what we've already talked about. We had Perl, then we have PHP, then we have Ruby. I'll just do a little linear thing. We're obviously leaving some stuff out of here. Then we have Python. And then let's just throw Node in here. Okay, but the punchline for what I'm going to convince you of is that all of those languages all took a lot of cues from the C programming language. All right, so what we're going to focus on, what we started focusing on today and what I'm going to finish focusing on next week is this idea that C is the grandparent of all these things. If we can understand the foundation that C created for us, we can understand all the technologies that exist today as well as the technologies that come out tomorrow. So our learning curve goes way down and we can start appreciating computer science as a vocation, computer programming as a skill set, and stop thinking about, oh, I'm a Java programmer, or I'm a Python programmer, or I'm a .NET programmer, whatever the hell that means. Okay, so I'm going to stop it right there. I will hang out in the room here for a few minutes. If you have any questions, I'm happy to answer them. Otherwise, I'll make sure the recording gets up and the slides get up and get shared. I'll go ahead and paste, here, I'll just create a slide real quick so you guys have it. If you need to contact me for any reason with questions, my Thinkful address is mlitman@thinkful.com. So feel free to email me there with any questions you have. So there's that, but I'll go ahead and chill in the room. If you do have any questions about any of the stuff we've talked about or want to know if I'm going to be talking about anything, I'm happy to answer that. So hit me with your questions.